Okay, guys, I am going to do a demonstration for you on relative humidity. That's your EQ for today. And the first thing that you have to realize is that inside this container that looks empty, oops, little water, it's not actually empty. What's in there? Hey, Papa, what's in there?
It's empty.
Nope, not empty.
Air.
There's air. There's air in that jar. So what does that literally mean? What kind of air? What's in our air?
You got different things, all kind of elements.
What is the number one element in the atmosphere? Kids?
Oxygen.
That's number two. Oxygen's number two. It's number one in the Earth's crust, but it's number two in the atmosphere. It's the one you always miss.
Carbon dioxide.
No, but that's one of the higher elements that we keep putting in the atmosphere.
How many more guesses do I get?
Two. I'll give you two more.
Not carbon monoxide.
No, we put that up there too.
Oh.
You don't think of it. Starts with an N.
Nitrogen?
It's nitrogen.
Really?
78% nitrogen.
Really?
21% oxygen. 1% everything else. A lot of which is carbon dioxide. Now, so we have all of those molecules in here, but even if I cover it, I could still put more stuff in there. That's because it's a gas and those molecules aren't really touching. So that means there's space in between there, right? So when you're thinking of relative humidity, what you're really thinking of is the other stuff that's in here. And what else is in our air?
There's moisture.
Moisture. That's what we're looking for. We're looking for water. There's water in the atmosphere. And when you're talking about relative humidity, you're talking about how much water is in a particular parcel of air, or how much water is in an air mass. And you're looking at how much is in there compared to how much could be in there. So really, relative humidity kind of boils down to temperature, all right? And we understand temperature. We understand convection currents. So I have 4 different size containers, all clear containers, just to show you this little demo. This container is about 50% full of water. That means in this parcel, or this air mass, this parcel of air, 50% of its space is full of water. Now, if I heat this air mass, if I heat this parcel of air, what's going to happen to those molecules? How are they going to behave?
They expand.
They're going to expand. Very good. When you heat that matter, it's going to expand. When you heat the air, it's going to expand. And when it expands, there's even more space. There's less air in that same space, so it's less dense. Remember, that's why hot air rises. But there's more space when you heat the air. So let's heat the air parcel. This is now that heated air parcel. It's larger because the molecules are more spread out, but it's the same amount of air that there was. I put it all in there like that. Now, 50% relative humidity at this temperature. When it's heated and I pour that same amount of water into that same air mass, you can see how now the relative humidity is much, much lower. The relative humidity now is more like 20%. Same parcel of air, same air mass. All I did was heat it. It expanded, gave us more space for the water to go into. Are you with me?
Sure.
Okay. So,
Are y'all with her?
are you with me? Clayton, Marvin, Logan Gallman, I will punch you in the throat. You too, Hanneman. So I'm going to take this same big parcel of air that I heated and I'm going to cool it down. What are the molecules going to do when I cool it? Papa.
Do what now?
What are these molecules going to do when I
They're
cool
going to contract.
They're going to contract, and that's going to squeeze them closer together so there's less space for the water to
They're
be
more
held.
dense.
More dense, very good. So I'm going to pour it in this smaller, cooler parcel. Now look at that. Just look at it. Okay, same parcel of air. We cooled it down. We lowered the temperature. and the relative humidity went up. Same amount of moisture, same amount of air, different temperature. The relative humidity is now like 90%. So what if, and Papa, where'd you get this little glass?
Mm-hmm.
Oklahoma? You put your medicine in there?
Nope.
Oh, okay.
That's from my libation.
I understand. So, this is now our air parcel. I've taken this air parcel, I've cooled it, it's almost freezing. It fits in this tiny little cup, same amount of air, same amount of moisture. What's going to happen?
It's going to run over.
Your cup runneth over. Do you know what we call that in meteorology?
Nope.
Dew point. It's when it
When it
rains.
rains.
Very good.
You rained on my table.
All right, love you guys. Thank you, Papa. You can stop it now.
6 minutes.
Hey, that's good.
I didn't-
Oh,
I didn't-
it's still going.